Hi and Assalamualaikum. My name is Yusrafidri Yusuf and I will introduce about the system that we choose as an application from second order system. We have chosen the system of car suspension as our product application. The design of front and rear suspension of a car may be different. So, this is the example of front suspension of a car. Suspension is the system of tires, springs, shock absorbers and linkage that connects the vehicle to its wheel and allow relative motion between it. Suspension system must support both road handling and ride quality. Tuning of suspension involves finding the right compromise. The work of a suspension is to provide comfort for smoothing out the ride and keeping the car in control. The control system has been used in the car suspension system where the suspension spring based on the load of the car weight. When drive on the road, car tires naturally roll over various imperfections and bumps. Those bumps interact with car wheels, applying force each time. The laws of physics dictate that every force exerted on an object has magnitude and direction. Next, this is the block diagram of the car suspension system. The type of the loop is closed loop. The input is from the desired suspension and the output is the real suspension. In this system, it has been controlled by mass of the car and the bump on the road. So, spring and damper will function as processor or plan a form of feedback for the desired suspension. We can get feedback from the response of acceleration of spring and damper. Last but not least, the two core components, spring and dampers, both play a vital role in this process. The shocks or dampers absorb the impulse, with kinetic energy traveling along the dampers instead of transmitting to car cabin. Meanwhile, the springs attach to suspension flex and expand to control the dissipation of the kinetic energy. They prevent suspension from bouncing up and down too much as well. Combined, both of these components keep car ride feeling relatively level and even. Thank you.
Hi and Assalamualaikum. I am Nazira Akila binti Nadi and I will explain for the calculation part. First of all, in this section, we will determine the transfer function, the second order transfer function, and calculate the peak time, settling time, rise time, and percentage overshoot. Lastly, we will use MATLAB software to do the simulation. To determine the transfer function, we will use Newton's third law of motion method from the free body diagram, where m is the mass of car, k is coil spring, and c is damper. We will get this equation, and f is get from the response where the car is moving on the road and cause dampness occurs. We will get ms squared plus cs plus k for xs and cs plus k for f. So, the general equation of the transfer function is Gs equal to Xs over Fs equal to Cs plus K over Ms squared plus Cs plus K. Then, for the information of the system, whereas M equal to 305 kg, C is equal to 1328 Newton per meter, and K is equal to 17475 Newton second per meter, we will get X over F equal to 1328s plus 17475 over 305 s squared plus 1328s plus 17475. For the general equation for second order system is Gs equal to omega n squared over s squared plus 2 zeta n s plus omega n squared. And then we compare the general equation with our transfer function equation and we get Xs over F equal to 4.193s plus 58.1531 over S squared plus 4.4193s plus 58.1531. Therefore, omega n is equal to 7.6258 and zeta is equal to 0.2898. From the information of natural frequency omega n and damping ratio zeta, so we can calculate the peak time, settling time, rise time, and percentage overshoot. The peak time obtained is 0.4304 second, settling time is 1.8 second, rise time is 0.3016 second, and percentage overshoot is 38.63%. By using the MATLAB online software, we can get the system response. First of all, we can use any letter to define our transfer function. So, we will use m as our transfer function. So, type the command m equal to tf and insert our numerator 1328 and 17475. Then, don't forget the comma here and insert the denominator 300.5, 1328 and 17475 and also the semicolon symbol at the back. Next, type the command of step plot M to generate the graph. Make sure that the letter is similar with the transfer function above. So, press enter and this is the graph for the system. Then right click to get the information from the graph. So this is for the peak time. As you can see here, the information of percentage overshoot also shown. Next, you can use to get settling time, rise time and also the steady state value. Then we can get all the information by type at the command data equal to step info M, which is for our transfer function. And this is the data that we can get from the simulation. Then this is the comparison between the data get from the simulation and also from the calculation. As you can see, there is no big difference between the two methods. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ilya Maisarah binti Hisham, and for the next presentation, I will present about the calculation of transfer function and the flow of transfer function. Okay, for the next slide, as you can see from the transfer function system, below is the system that have been converted to the state space representation. Okay, from the transfer function, we separate into two, which is the denominator and the numerator. The denominator is used to find the state equation and the numerator is to find the output equation. Okay, for the next slide, as you can see, that is our state equation calculation. And next is to find output equation. And the next slide is the table of the Routh-Hurwitz method, table methods. Okay, from the table above, there are no sign change in the first column of the Routh table. Therefore, the system is stable because there is no poles exist in the right half plane. As you can see, there is no poles exist. Okay, next is the calculation of the steady state error for step input, ramp input and parabolic input. Okay, as you can see, that is the statistic error constant. There are three, that is position error constant, velocity error constant and the acceleration error constant. Okay, next slide. As you can see, after we have find the equation, we start to calculate the steady state error and insert this value into each unit step input such as step, ramp and the parabola. That's all from me. Thank you.
My name is Muhammad Arzadam and I will present about the discussion and conclusion the application of second order. As we choose the suspension as the application of second order, car suspension system is functioned to provide steering stability, good handling and supporting the weight of the vehicle. In fact of that, spring and damper is able to control the suspension and finally we found it will cause rear suspension. So this is the suspension of the car suspension. Compared to the general equation, we can know the natural frequency and damping ratio so that we can calculate the peak time, settling time, rest time and percent overshoot. So this is the graph from the MATLAB application. From the graph, we can see that it took 1.7427 seconds to reach a steady state. The type response shown in the graph is called as the underdamped response, which approaches a steady state value via a transient response that is damped oscillation. So this is the Routh-Hurwitz table. From the table, we can know the system is stable because no sign change in the first column, so there is no pole exist in the right half plane. After making calculation of steady state error for of step input, ramp input and parabolic input, we found the system type of car suspension is type 0. In conclusion, control system is the main system to make sure that the system is run smoothly. as we choose the car suspension as our control system. So the suspension is important to make sure the car handling and the right quality in better situation. The suspension will react to the load that the car carried and the contact between the tire and the surface, which is the road with a hole or bumper. In this situation, the load and the road surface are the controller and the reaction of the suspension is planned and the rear suspension is the output. So, car suspension can be considered as the control system for the car and the system is stable.